All right, if you're on this video, it only means one thing. You didn't understand how to balance equations like we did last time, all right? So let's look at that way of balancing equations, all right? So remember, guys, when you balance equations, the only reason why you balance equations is it has to follow the law of conservation of mass, all right? So again, the reason why we balance chemical equations, guys, is it has to follow the law of conservation of mass because balanced chemical equations are actual representations of chemical reactions, real life chemical reactions. All right, so this is how we did it last time. So if you look at this equation right here, how did we balance this? First of all, you draw a line in the middle, okay? And then what we did was we listed down all the elements on the left and on the right. So for example, on the left, we got N, then there's two N's there. On H, you got two H's there. And on the right, you got N is equals to 1. And then H is equals to 3. And then we balanced elements that are not the same. You know, if they're not equal, we balance them. How? By multiplying a number, okay, to the lower side, okay, and that number becomes your coefficient. So again, we multiply a number to the lower side to make them equal, and that number that you use to multiply it is going to be your coefficient. So for example, let's see this one right here. So on the left, you got n is equals to 2. On the right, you got n is equals to 1. So on the right side, you need more n's. So again, think of a number to multiply, not add. Multiply the n, okay, such that they become equal. So if you think about it, that number is going to be 2. And that 2 is going to be your coefficient that you put in front of the compound that has the n. So that 2 that we just multiplied is going to be our coefficient. So let's find our n. N is right here. Okay. So I have to put that coefficient in front, so the 2 goes there. But if you look closely, that 2 also multiplies the h. Okay. So here, 3 times 2, you get 6. All right. So if you look closely, n is now equal, but h is not. So h is not equal. All right. So how do we make h equal? So again, same process. You just find a number to multiply the lower side to make them equal, and that number that you use to multiply it becomes your coefficient. So on the right side, you have 6 h's. On the left side, you have 2 h's. All right. So what number do you multiply to 2 to get a 6? Well, it's going to be a 3. Okay. And that gives you a 6. So that 3 right there becomes your coefficient, and you put it in front of the compound, okay, that has the H. H is right here. See it? So I'm going to put it in front there. So 3. Now look at that 3. Does it multiply anything else? No, it doesn't. So we're good. So now look. N is 2 and 2. H is 6 and 6. So we're done. So this is our balanced chemical equation. Okay. And this is a 1. Don't forget, if it's a blank, this one is a 1. All right. So this one was balancing element per element. Okay, we balanced this one by doing an inventory of elements and then balancing it one by one. All right. So if you didn't get that, let's go to another way of balancing it. All right. This one is called the copy method. All right. Some people call it the packet method. I call it the copy method. All right. All right. So this one is called the copy method. Okay, in the copy method, instead of balancing the equation element per element, we're going to balance them molecule per molecule or compound per compound. All right, so what we're going to do again, guys, is balance it molecule per molecule, compound per compound. All right, so let's see. Same steps as always. Okay, divide the equation into 2. All right. Divide the equation into 2. Now you start with the very left element. So the very first one on the left. So n. Okay, look at your n. How many n's do you have there? You got 2. All right, compare it. So how many n's do you have here? You got 2. Compare it with the n on the right. You only have 1. So which side needs more n? It's going to be the right side. So you need more n's right here. Okay, so instead of adding just an n or multiplying it by a number, what we're going to do is we're going to copy the entire molecule. So what we're going to do is we're going to copy not just N, we're going to copy the entire molecule or compound, NH3. So again, since NH3 is the side that needs more N, I'm going to copy the entire compound for NH3. So N, okay, again, there's only one here on the right side. So there was two here on the right, on the left, and there's only one here. I had to copy the one that has N, so NH3. Now look, so let's start counting again. On the right side, I have two N's. I have one, I have two N's. You see it? And so there's now two here, two N's. Okay, two N's on the left, two N's on the right, so I'm good. Okay, so N now is good, remember. Okay, so N is now equal. So what do? Go back to the left side and move on to the next element. So on the left, you got H. And how many H's do you have? Two. Okay, now look on the right. How many H's do you have? Well, H is 3, and another H is 3, a total of 6. So again, on the left, you got 2 H's. On the right, you got 6 H's, right? So 2 versus 6. Okay, so how do you make it equal? So you need more H's on the left side. All right, so again, you need more H's on the left side. So did we just add H? No, you have to copy the entire molecule. That's why this is called the copy, or the packet method. So copy method, copy the entire molecule. So copy H2. Okay, now if I copy it once, look closely. So I got 2 H's, 2 H's. The total now is 4. Okay, but we need 6, so that's not enough. So what do you do again? Copy it again. See it? Now it's 6. Okay. All right. See it? Okay. All right. So 6 H's, 6 H's. Now, what you do now is you go back to start again and check it. Again, you have to do this 3 times just to double check if everything balances out. So check. How many N's do you have here? Okay. How many N's do you have on the left? You got 2. How many N's you got on the right? N is equals to 2. All right. Look at H. On the left, how many H's do you have? 6. How many H's do you have here on the left? On the right? 6. So I'm actually done. All right. So this is it. Okay. So how do you put in the coefficient? Well, the coefficient, you just count the number of molecules, original plus the copy. So look here. For N2, there's only one N2. Therefore, I'm going to put in 1. Okay. For H2, how many H2s do you see? 1, 2, 3. So therefore, I'm going to put in my coefficient as 3. Okay. Finally, in H3, I got 1, 2. So there's 2 there. So I'm going to put there 2. And that is a balanced chemical equation for that one right there. Okay. So again, that's your copy method right there. Okay. Let's try it out again. All right. Let's try it out again with this element right here. Okay. So as always, again, divide the equation into 2 parts. Okay. Wait a minute. This equation is wrong. Okay. So that equation is absolutely horribly wrong. So let's just skip that one. Okay. Let's skip that one because that one's wrong. All right. Here we go. How about this one right here? This should be better. Okay. Divide it into 2. All right. So again, start with the element on the left. So start with the very first element. So Fe, how many Fe's do I have here? I have here 1. On the other side, how many Fe's do I have? There's actually 2. So I need more Fe's on the left. So what do? I copy the original compound, the entire compound, not just the element, right? The entire compound that has the Fe. So since it's just Fe, it's just going to be Fe. Okay, so Fe now is 2. All right. Okay. All right. So we're done with the Fe. Let's move on to the next element, O. On the left side, I have 2 O's. Okay. On the right side, I have 3 O's. Okay. So which side needs more O's? On the left. Okay. All right. So again, you have to copy the entire compound. So I'm just going to add O2. You can't just add O. It has to be O2. Okay. What does that change? O now has 4. 4 O's. Okay. Now look. Now this time the left side has more O's than the right. So you need to add now more O's on the right. Now wait a minute. Can you just add an O like this? No, you can't. In the copy method, you have to copy the entire compound. So instead of writing down O, do we just write down O3? Still no. It has to be the entire compound. So you have to write down Fe2O3. See it? Okay. Now, if you do that, a few things changed. Okay. The O becomes 6 and the Fe becomes a 4. See it? Okay. Now look, we're still at O, right? So you got 6 O's on the right, 4 O's on the left. So you need more O's now on the left. So again, we add another O2 here. All right. So again, erase that. So you got now 6 O's. All right. So O's are now the same. So we're good with the O. How about the FEs? You need more FEs on the left. So I need to add FE. That's what? 3. Another one, 4. So this is now 4. Okay. So this changes now to 4. All right. Go back to start and check again. Everything looks good. So the correct answer for this one would be what? Okay. Again, to get the, so let's erase this so we can put more stuff on it. So again, how do you figure out the coefficient? You just count the original plus the copy. So 1, 2, 3, 4. So there's 4 of them. So the answer here is 4. How about this one? 1, 2, 3. So this would be a 3. And if you look closely here, 1 and 2, there's only 2 there, so this would be a 2. And this is your balanced chemical equation. You see it? All right, let's try another one. Okay, let's try another one. Okay, how about this one right here? All right, let's do this really fast. So again, divide it in half. Okay, start with the first element. So the first element here is K. How many K's do you have here? 1. How many K's do you have on the other side? 1. If they're the same, move on to the next element. All right, the next element on the left is Cl. How many Cl's do I have? 1. On the right, how many Cl's do I have? 1. Okay, again, move on to the next one. So O, you got here 3. Okay, on the right side, O is equals to 2. So you need more O's on the right. So again, since this is a copy method, you copy the entire molecule. Okay, O is now 4. Okay, so 4 right there. If you look closely, the left side needs more O's now. Okay, so I'm going to copy the O's. But wait, again, since I need to copy the entire compound, it changes all the numbers now. So what happens here? Okay, my K is now a 2, my Cl is now a 2, and my O is now a 6. All right, we're still at O. Don't forget, we're still at O. So now O on the left is 6, on the right is 4. So I need more O's on the right. So I'm going to add another O2 here. Again, it has to be copying the original. You're copying the original, right? So if you do that, O is now 6. O is now good. Okay. All right. Since that's the last element, go back again to start. Again, you have to do this 3 times, 3 passes, just to make sure everything balances out. So look at K. K is 2 on the left. On the right, K is only 1. So I need to copy K. But again, you copy the entire compound. All right. So that changes K to 2 and the Cl to 2. All right. K is the same. Okay, let's check the others. Cl 2 and 2, correct? O 6 and 6, so we're done. So again, how do you figure out the coefficients? It's the number of copies plus the original for the compound. KCl03, there's 1, 2, so therefore the coefficient is 2. Okay, KCl is 1, 2, so the coefficient again is 2. And finally, O2 is 1, 2, and 3. So therefore, the coefficient is 3. And this is your balanced chemical equation right there.